Welcome back to physics. Let's go ahead and continue on uh, talking about impulse. And by the way, impulse can be stopping something or it can be uh, accelerating something, right? If I have like a baseball bat and a baseball, the longer I keep contact with the ball, the more uh, acceleration, I can add more energy to the system, right? Okay, let's jump over here real quick. Okay. So let's do some calculations for an egg drop here. So I want to know about how hard, if I drop an egg from 3 meters, how can I calculate how hard it's going to hit the ground? Yeah, I think I can. Let's try that. First thing I need to know is the weight of the egg. And so I went ahead and looked that up, and the average chicken egg is equal to 70 grams. Okay, and I'm going to want that in kilograms. So I got to move my decimal place 3 to the left. 1, 2, 3. So the average egg is going to weigh 0.070 kilograms. I believe I did that math right. All right, that's the first thing we need to know. The second thing is, because we're dealing with impulse, right? Force times time, right? But impulse also equals momentum, and I really want to know what the momentum of this egg is. And momentum is equal to mass times velocity. Well, I've got the mass. Let's find the velocity, okay? We're going to drop it from 3 meters. So I went ahead and looked up the formula for this, and it is velocity. Now, this is a special case. Of course, we were talking about this in earlier chapters, earlier modules, that velocity is the change in distance times the change in time. And so we could figure that out, but there's another formula we can use that I would prefer to use, and that is velocity is equal to 2 times, take the square root of 2 times gravity times the height. The acceleration, g is the acceleration due to gravity, okay? So let's go ahead and let's calculate velocity because we already know our mass. So we're going to take the square root of 2 times 9.8 meters per second squared times our height. How high are we dropping it from? We're dropping it from 3 meters. Okay, and then we can go ahead and do that. Now, let's grab the calculator. So, 2 times 9.8 times 3 is equal to, that is equal to 58.8, I believe. Let me double check that. 58.8. All right, and that is meters times meters, so meters squared, over seconds squared. And this whole thing is square rooted, okay? So next thing let's do, let me pop up a calculator here. I've got 58.8, and I want to take the square root. Where's my square root on here? I'm seeing my squared. I'm not seeing. Yep, that's it. Yep, that's it. All right. So I end up with a velocity just before it hits the ground of So V is equal to 7.67, I think is what it was. Let's go look back. 7.67. All right. And notice I've got meters squared second squared, but because I take the square roots, I end up with just meters per second, which is good because that is the units for velocity, right? Okay, so next thing, I have my impulse is equal to force times time, okay? Let's go ahead and plug in a few things. What do I know? I know, oh wait, I need to find the momentum first, right? So my momentum is equal to my mass, 0.070 kilograms, times my velocity, which is 7.67 meters per second. Let's go ahead and pull up our calculator. 7.67, yep, times 0.07. All right, and that gives us a momentum. I'm going to pull this up so I can see it in the upper. There we go. So momentum is equal to 0.5367, and this is kilograms times meters per second. All right. Now I can use impulse. Now I can use that to convert. This is my momentum has the exact same units as impulse, so that means that it's the same thing, right? So I can say I want to find the force, so I'm going to divide both sides by time. Okay, and I'm going to say 0.5367 kilograms times meters per second divided by time. Let's do a really short time. Let's say that this is the egg hitting the concrete, and instantaneous, almostly it stops, right? So we're going to go 0.01 seconds. Okay, and that is going to equal my force. All right, so let's go ahead and do the math again. So that number right there, I like that number. We're going to divide that by 0.01 equals, that's 53.67. 53. So my force is equal to 53.68, and that's kilograms times meters. Now notice I've got seconds times seconds here on the bottom, so that's seconds squared. Okay. Now let's take that exact same momentum. Let me pull that back down a little bit. So we're going to take that exact same momentum, 0.5367, and let's divide that by 0.2 seconds. Okay, that's still kilograms meters per second. Let's go ahead and do that math really quickly. I think I might be able to, maybe not. All right, so this is 0.5367 divided by 0.2. Look at the difference there. So instead of being 53 newtons, 54, it's 3 newtons, okay? So it's, my force is equal to 2.6835 newtons, right? Or kilograms times meters per second squared. So going from 0.01 seconds to 0.2 seconds, that force decreased tremendously. And if I could spread it out over half a second, that would be even a smaller force. Okay, we'll come back in our next video and talk more about what we need to do. So glad you're here. Talk to you soon.